Now, coming to the core of the release engineering. So if you understood in the beginning, I used to say we call this as release engineering. Okay, so as we saw, specifically when you're talking from the build and release management, all the activities is based on the particular improvements or the area of improvements, and the domain or the discipline, what we call specifically, is the name based on what activities you will do. So as per that, this process is completely called as release engineering. So what do you mean by release engineering? So generally, release engineering is the one which drives all the products from coding to the release management. So any kind of activity that happens between the development and QA, that is compilation and then linking and then delivering of this whatever object files that you have created to the shareholders, is called as release engineering. So in release engineering, if you see, there are various disciplines like software configuration management, and we have build management, then we have continuous integration, then you have certain others like packaging management, continuous delivery. So like this, based on each and every activity, what you can do in your release process, the modules can be splitted. So for that, if you see specifically, we saw from SEM and continuous integration, wherein for SEM, we were doing some kind of activities wherein you can store the code and maintain it, right? Now, the other part, what is very important is now you think as a developer. So he wrote the code and everything is fine. Now, how is it he's going to give this to the rest of the world? So the first thing is, before he gives to anyone else, he has to give it to the QA to test it, right? So how is the QA going to use them for testing? So they cannot use the files raw, right? So build management is that process which assists any activity that happens between development and QA. Okay, so if you see in that perspective, what is build management? So build management is nothing but a process which mainly focuses on compilation, assembly, and creating deliverables. So when you mean what compilation and assembly is, that the developer will be writing a source code. Okay, now that has to be first converted into a machine readable form so that whatever you try to run and execute should be as a deliverable, right? So that process of converting the source code into a machine readable format is what we call it as compilation. So what do we do in that? We convert those source code, whatever the developer has written, into something called as object files. Okay, now for every source code, you will be getting one object file related to it. That is, you take the code, you convert that into machine understandable format, and you create something called as object file. For example, you write Java file. So when you compile a Java file, you will be getting a class file as an output. You'll be writing C file. When you write a C++, when you compile it, you will be getting a .o file or .obj file, which is nothing but objects. So like this, for each file as a source code, when you compile, you'll be getting a corresponding object file. That is compilation. Now, once you compile these object files, again, as a product, you might be having hundreds of files, right? So you'll be having hundreds of object files. So is the QA going to test all these hundreds of files? No. Again, because they need something as a package, because they need something as together, because they cannot test components separately, right? For example, one simple say I can say is that you have broomstick. So if you see broomstick, I'm saying typically your traditional village type, you'll have so many sticks together bound inside it, right? I mean, don't think why is he using this example. I'm just giving it. So if you see, it looks like one bunch only putting many sticks together, they can do some functionality out of it. But if you see internally, it has single sticks, but put together so many of them forms one single component or product. So in the same way, they cannot just make use of one object file. So what we have to do is we have to club together certain object files. So internally, whatever functionality it has to do, based on that, we will be clubbing together, and then we'll be creating one deliverable out of it. Okay, so those kind of deliverables, we call it as artifacts, because in the world of build management, you will be hearing this a lot of time: artifacts, deliverables. So what are they? These are nothing but the exact files which a person will be using. That might be a QA, or when you're giving to the customer, he will be using it, he'll be accessing it, and he'll be doing something based on those files, like a exe or a DLL, a jar file, var file, right? All these kind of files are called as deliverables, which will be created by assembling all those object files. So that step is what we call it as linking. So specifically when you're worked on C background, you will understand that we always call it as linking. That is, we create some object files, we group it together, and we create it as one deliverable, and we deliver it as a DLL, exe, jar files, or whatever is the format that you want to give. Okay, so this process of focusing only on these steps, that is compilation, assembly, and delivering it to the stakeholders, is what called as build management. Okay, now the next question comes is, okay, there's something you're trying to do as build management is fine. Now, how do you achieve automation in this? Because if you see, everything is done manually. And as I said, release engineering is going to focus on those areas which is going to help the internal team or the process to achieve the release at an earlier stage. So in those terms, what will happen is we need complete automation. So for automation, what is that you're going to do? So, and that too, especially what automation we are trying to do, we are trying to automate the build management. So any automation that you're trying to do for the build is called as build automation. And how are you going to achieve build automation? Build automation is generally achieved by writing some kind of scripts. Okay, so that whatever steps that you can do manually, you can write one small script and you can automate it. If not, right now in the market, there are some specific tools which can do all the build activities. Okay, so those kind of tools are called as build tools. So any tool that is going to assist only the build activity, that is compilation, linking, and creating the deliverable, is called as build tools. Okay, so just like what we saw tool for SCM, some tool like Git, or we have many other tools like Subversion and uh, Perforce. And similarly, for continuous integration, we saw one tool like Jenkins. So in the same way, we are going to see now a tool which is going to assist mainly in the build management area, that is compilation and assembly and creating the deliverable. All right. So what and all things can a build tool do? So based on the current agile methodologies, if you see, we don't want to stop anything only to the build, especially when you're saying continuous integration and all. We can do much more things, not just doing a build management. So as a build tool, if you take, it can do basically compilation of all the source code, then it can do a assembly and create the binaries or deliverables. And after that, if you see specifically from Java side, you can write unit test codes for your source code and run unit test against the source code to verify that whatever object files that you have created are completely fine. Okay, and then what do you do? In case if there is a need, you can even do a deployment and test whether the deliverables or the binaries what you have created are completely fine. Okay, and sometimes you might be requiring to do some documentation. If needed, you will do. I'll focus more on documentation when I'm going through some topics in Maven. But other than that, if you take a build tool can do all these things. That is compilation, packaging, unit tests, and deployment. Getting it?
Yes.
Okay. Now, let's just quickly see what are the advantage and why do we really need a build management or a build automation or a build tool. So if you see, by using a build tool, the first thing it is going to do is eliminate the manual task. So you will be doing so many manual tasks. Okay, so what and all you'll do. For example, you take a product. So in the product, you might be having multiple components, right? And when you're writing code, you will be creating different folders for each component, and within that, you will be storing everything. Now, each component itself might have some 100 files. So if you're trying to do everything manually, first thing is you need to manual all the 100 files. And if you see the kind of work that you will be doing here, it'll be repetitive task, which means if you use some command for compiling one file, for all the 100 files, it will be the same command. Pretty much the name will be changing. That is, if I say 1.java, instead of 1.java, I'll be saying 2.java. Instead of 2.java, I'll be saying 3.java. Like this, all the 100 files will be having the same command to run. And the second thing is, when you are trying to run as a product, there might be some dependencies, which means one component may be dependent on other component. So if you see, there might be some header files or some libraries which is required by other files to compile. So unless and until you don't first compile the dependencies, you cannot compile the other ones. So what you have to do is you need to know the order of the compilation of which files you have to compile first, and which files you have to compile later. So in this way, when you're trying to do manually, there's a lot of dependencies, and you might be chances are there that you might be missing some steps. So when using a build tool, you can write all these things, put up all the dependencies, you can say the complete workflow and the order of the build in the build tool. And you don't have to repeat everything by yourself, and the build tool can take care of repeating all the steps. So that is one of the biggest advantage. And the second thing, as I said, you can do things at a higher pace. That is, when you have to do 100 files, obviously you will be doing one by one. Okay. Or how is that you will manage two things at the same time? It is quite hard for as an individual for us to do multitasking, right? Because I cannot open two windows, and I cannot type from one hand, from left hand, the other one in the right hand, and I cannot see one eye here and one eye here, right? It is not going to be practically easy. So we have to do one after the other. So instead of that, if you use a build tool that has options to do things parallelly, now, which is advantage? Rather than, like, if I say for compiling one file, it takes 1 minute roughly. For 100 files, it is going to take 100 minutes. So we are going to sit 100 minutes in spending some time. Instead of that, if I use a tool, automatically it will do some things in parallel. So within like 20 minutes, it can do compilation of all 100 files. Now that is far better for us, right? Wherein we don't have to waste so much of time. So that is one of the other advantage of build tools. And since you are trying to automate everything and there is no chance for going with an error, if you see the quality of the process, what you're trying to do will be higher. That is, the quality of the product is always going to be higher. And the problems or the breakages which the build is going to consider, that is when you're trying to compile, that is what we call it as build going forward. So in simple, build means compilation, linking, and creating a deliverable. That is what we refer it as build in short. So the amount of time a build can fail because of manual intervention or manual mistakes wherein you forgot to give some step which is required. So these kind of errors or these kind of failures are not going to happen if you use build tool, because you would have defined everything there and that will take care of. And that is what the point here says, that minimize the bad builds, because everything is going to be defined completely in those tools, in the build tools, and that will take care of all the steps it has to execute. And now what is that it is going to have? The other thing, like I said, in Jenkins, if you have seen, it keeps a track of all those things what you're doing, right? So in the left hand side, we were defining some build history for 4 or 5, so that it'll keep all the information until the time that you want. This is the advantage of the build tools also, because if you're doing builds daily and if you have to keep a track of everything and log of everything, it is not easy. Again, we have to write logs, keep maintaining everything, right? So instead of we doing it manually, using a build tool is always better, because it gives a complete history of what you did, when you did, all those information can be tracked. And finally, the important thing is, by doing all those things, what is that you're trying to achieve? You're trying to save the time of the engineers, and you're trying to save the time that is being used by the release process. That is, you will be releasing it early. Now, because of this, what is that you're going to get? Basically, all the time that you're going to reduce is in turn going to be money for the company, right? So this is why build management is very critical from a product team or any team who has to do some kind of releases. Getting it?
Yes, yes.
Any doubts in this, or just an overview?
Yeah, it's practically when you're talking about, suppose I have 100 jars which is supporting for one project,
Hmm.
and the team is in and out, they are working for enhancements, customizations, lot of things are happening on other hand.
Hmm.
So the newly developed jar files or whatever it is, it's built as a part of build management. What we are trying to do is, so we'll for minimize the, I mean, bad builds or whatever. We will take the control and moving to production. With addition to these things, these are and all will come under the build management, right?
Yes, exactly.
Okay, okay.
Yeah, we'll go through all those things, whatever you said in this specific class. So wherein we'll understand how build happens, what and all things are there. But before going into it, it is very much important. You should know what is build management and why it is required. Okay,
Yes.
and the other thing now, why is it a separate team needed to do a build management? Okay, if a developer can write code, if he can write hi-fi code, spending 2 days, 3 days, can't he spend another 5 minutes to do a compilation and keep everything ready by himself? This is one of the question which you might be thinking. If not, why is it we need? Because people would ask you as a developer, I mean, what, you guys are so big, is it? Why do you need a separate team for doing it, or a separate engineer? Now, if you try to understand that, there are 4 things which is very important, because of which we need release engineering, or because of which we need specifically build management. So the first thing, if you see, reproducibility. So anything that is being done should be able to reproduce. So if you take a developer's environment, what will happen is he will be having so much of latest tools or so many third-party tools in his environment, and he'll be working on everything. Okay, so it'll be hard for him to maintain the same environment always, isn't it, practically? So you'll be doing some new things for new stuff, try to achieve that, try to simplify your task, and you'll be doing it. But one of the key role what we has to have is whatever environment that we are working on should be first equivalent to the customer's environment. Only then we can ensure certain things that whatever that I'm going to deliver will work in the same way in the customer's place. So who is going to maintain that kind of environment, which is not possible by the developer literally. So we need someone like a release engineering, that is a build management or a build team, whose environment will be close to the customer's environment. Okay, so now why do you need such a kind of environment in our place? That is because if a customer comes back and says that there is some kind of error that is happening, so the customer can be an external customer or they can be an internal customer. So when I say internal customer, it is nothing but a QA team, okay, or a performance team who are going to consume the build and work on them. So when someone comes back and says that there is something not working, then you might have to recreate the scenario for testing purpose. That is, reproduce certain things. So to reproduce certain things, you need to have the same environment which it was used for doing that kind of build, right? So suppose say that you use some specific architecture operating system. I mean, you used a particular Linux architecture and you were doing the build. After some 1 month, there is some need where you have to recreate. If your environment, that is your server, the scripts what you used is not in the same place, and if it is not of the same when you have done the build previously, then it is going to be hard time in reproduce everything. So that is when we need an environment which is close enough to the customer. Okay, and this environment will be helping to reproduce anything specific to the build at any given point of time. And talking about repeating, it will be a stable environment because a developer's environment will not be stable because of putting in so many things in its place. So having an environment which is stable, consistent, and close enough to the customer's environment is called as a build environment. And therefore, we refer the build environment as a formal environment, which means it is exactly equivalent to what a customer will be having. So in these terms, now what we will be doing is, even though a developer writes his code, he will be verifying only from his changes. He will not be worried as a product, wherein we as a build team, we will be worrying as a product. And the environment what we will be having, we will be always doing activities which is going to be pertaining to a product and not just to one single file or one component. So when we refer as a build environment, it is going to be a formal environment wherein we take all the changes as a product and we do a build as a product. Okay, so that is why it is very important to maintain a separate build environment. And that is why the importance of build environment is also, because anything that has been given to the customer will be only from a build environment what you have built and given to the release. You guys getting it? Why is it so important now?
Yes.
Any questions?
So,
Vinay,
so it
Hemant?
means to say,
Yeah, Kumar.
uh, yeah, suppose I have a Java 1.5 which are working as a developer,
Hmm.
and the production is upgraded to 1.8 now.
Hmm.
So it's the same environment in the sense which I built a jar file.
Hmm.
Still, the production is accepting this 1.5 changes, whatever it is, and um, the tool is going to say if it is possible, it will give you an intimation, or the build management manually need to decide, okay, it's a 1.8, it's 1.5, no issues. I mean, straight away we can go with the deployment kind of thing.
No, here what happens is whenever we're writing the build tool, we need to support this kind of backward portability, and it will be allowed only if the customer is also going to do the same thing. So that is what we will be first doing in our build environment. So if a developer says that I have written a code in 1.5 or I have written the code first in 1.8, and we will say the prerequisite is the customer should also have 1.8. Suppose if there is something which has to be run in 1.5, the developer will write in 1.5 and he'll say, but when he's trying to give us that code, whatever scripts that we use, the build tools that we use, now that has to be modified in such a way that it should be compatible with 1.8 and also same time 1.5. Now, first we will write all those things in our build tool and we'll try to compile. Only if it works in our environment, we will just assume that, okay, this is going to work same in the customer's place also. So we try to decide those kind of things first in the build on run environment and then proceed. Suppose if we say that no, this is what we are going to give it to the release to the customers, and customers are not going to use 1.5. So in that case, in our build environment, we'll be having only 1.8. So unless and until using our build script, if it is not compiling in 1.8, then we are not promoting the code for further usage. So it has to be decided by the development, writing the code properly so that it will be compatible.
So we are acting as a QA, nothing more than that, right?
We are
Or
not QA,
part of QA.
we are assisting QA.
Okay, okay, got
We
it.
are assisting, okay, it is like a bridge between development and QA.
Okay.
So we ensure that whatever these guys do, it is fine, and we give it to the QA to proceed further. And once the QA completes, again, we will be taking this build and giving it to the release team. That is, we'll be giving it to the customers.
Okay.
Getting it?
Yes.
Any questions, Vinay, Hemant?
No, Adam, we're good.
Okay, so now at least do you guys understand what is the importance of having a build team?
Yes.
Okay, and why is it growing so vast? Because if you take some couple of years back, it was not so important, but right now people are understanding the importance of build management, specifically the release management, build and release. Okay, so now talking about that, uh, when you say build management, so there will be one engineer called build engineer who will be maintaining only the build activity. Just like what we saw, there will be one engineer only to do SCM activity, then he'll be called as SCM engineer. But what will happen when you are going to do many activities like this, then you will be everything put together, you will be called as build and release engineer. Okay, so if you're doing only build, you will be called as a build engineer. If you're doing only SCM, you will be called as SCM engineer. But if you can do build, you can also take care of the SCM activities. You will also handle the release activities. That is, we will talk more about what happens after the build, once we complete this module. So if you can do everything as a senior, then you will be called as a build and release engineer. Okay, so that is what I would have told this as an initially when I talk, if someone asks, what is build and release? So build and release is actually a combination of several tasks that you're doing. Okay, so wherein it is not just one part you're focusing on. You are focusing right from the build to the release to the customer. So all those things put together is called as build and release. Okay, so In that way, let's now focus more into build management. So we saw completely about what is build management, what and all you can do, right? So there are various build tools available to assist the build management. Now, these build tools depend on the programming language. Based on that, there are corresponding build tools. So if you take C, C++, we have make files. We have a tool called Makefile, which is going to help in the build management of the C++ project. So in the same way, if you take specifically .NET and all, then we have Visual Studio, which gives you MS related file. That's what we call it as. Then we have specifically for Java, we have Ant, which will be helpful in assisting the build management steps for a Java-based project. So in that case, now Maven is another tool which is going to assist the build management. Now, when we already have Ant as a tool which is there from closely 10 plus years, what is the advantage of using some other tool? So that is when people we're seeing what are the problems that we have using a build tool like Ant. So in this class, in this module, we are going to focus more towards Java-based system. Why? Because if you see from the IT world, the amount of work that has been done as Java is more, and that is why we are focusing specifically on a Java related tool. And the question again comes is that people are teaching Ant, why are you teaching Maven? So Ant is not an outdated tool, but it is a very old tool. People are looking for new features. People are looking for more automation, and that is when you need to learn a tool which is widely used currently and which has more benefits other than Ant. So in that case, Maven, if you see, is a tool which is completely written in Java, and it is going to be used for Java-based projects only. And it is, I can say, it is actually a tool or enhancement of Ant is what you can think. So it can do everything what Ant can do, and at the same time, it can do so many things which Ant cannot do. So if you have gone through Ant, you would see what I'm trying to say is that if you have to do some task in Ant, you have to basically define everything and write, and so much of coding is involved. Wherein in Maven, the amount of coding is very, very less, and it has the ability of doing so many other things. So that is why we'll be focusing mainly on that kind of tool wherein it is going to help us in reducing the time in doing the build management for the complete product, which is based on Java. So in that words, what is Maven? Okay, so Maven is a build tool. Yes, it is written in Java and it is going to be used for Java-based products or Java-based build systems. Now, why is it so important and what are its advantages? What we need to see. So the first thing is what we need to understand is Maven is not just a build tool. Okay, so what is that? Then what else is Maven? Maven is actually a project management tool. So when I say project management tool, what do you guys understand? So it is not just going to take care of the builds of the your project, whereas it is going to take care of managing the complete project. So what does that mean? What and all can it do internally as a project management tool? So what it does is basically in order to manage your complete project, it will break your project in the concepts of objects. So objects in the sense it is going to be breaking each and every component, and with small references it can quickly identify what is your component, what it has to be done, how it has to be done, all those things. Okay, and importantly, it is going to give you a set of standards. So you have to follow the standards, and if you follow the standards, the Maven can take care of the complete project. That is, it is going to manage your complete project if you follow that standards. And then second thing, it is going to give you a defined project lifecycle, which means Now, if you given a Java based project, you have to follow certain steps, you have to follow certain life cycle. That is, first you have to compile, then you have to do a unit test, then you have to create a jar, then you have to do a deployment. All those things are there. Now, do you know which step you have to do for first, which step you have to do second? Like, can I do a unit test after compiling, or can I do a unit test only after creating a jar file or a var file? So all this kind of questions doesn't matter for someone who is using Maven, because he will be following a defined life cycle, and if he just uses and works on the same steps of the life cycle, Maven will take care of managing your project completely. And not only that, Maven is also going to help you with managing the complete dependencies. So when I say dependencies, for your project, there might be some dependencies with respect to internal components, or there might be dependency with respect to some additional tools or libraries. So all those kind of dependencies will be taken care by Maven. Okay, so this is how internally Maven will be working. Now, when we are going through practicals, this is what we'll be seeing. So first, we'll be understanding each and everything what I said. So let's take some time and understand what is the standards that the Maven is going to keep, what is the life cycle that Maven is giving, what is the dependency management that it does. Okay, so these are the things we will understand, and then practically we will see how it is being implemented. So when we are going to talk further deep in Maven, as I said, Maven is written in Java and it works based on Java. So what happens is, whatever instructions that you give to Maven will be through something called as goals. Okay, so goals are nothing but the specific task which Maven wants to do. For example, if you say compile, create a jar, unit test, do a deploy. So like this, you will give some instructions to Maven, right? So all the instructions Maven will be taking through something called as goals. So we will see what is that also internally. And internally again, what are these goals? Goals is something you pass some command to it. But internally, if you see, everything that you pass to Maven is actually through some plugin. A plugin is nothing but a jar file internally. So that is why I was saying Maven is based on Java and it is driven by Java. So any commands that you pass are called as goals. But internally, if you see, these are nothing but plugins, which is nothing but a Java or a jar files. Okay. So to start up with, you just understand this much. And as we proceed internally, and we'll be seeing all those things. So any doubt right now? Are you just understanding something about Maven? I mean, you don't have to really focus what I was trying to tell, because I'll be explaining each and everything now. But for now, you need to understand, if I say Maven, it is not just a build tool, but it is a project management tool, and it is going to help us by providing standards, lifecycle, and a dependencies management system. Okay, so if you see what are the advantages of using Maven, is that these are the things. So now, like I said, since you are going to follow a set of standards, so no matter how many different projects you are working, you will be always having a uniformity, because it is the same standard you will be following across all the other places, right? So there will be uniformity across all the products. Because of the uniformity, it will be easy for you to maintain, because if every project is going to be completely different, then it is going to be a problem for us to maintain, because every maintenance is going to take some time. Now, if I'm saying that every project is going to look and feel almost in the same way, not 100% similar, but based on the standards, it will be the same way you will be approaching all the projects, then on working on all these things will be very easy, because if you know one project, and if you go and see in the other project, it'll be in the same step, so that it'll be easy for us to do any modifications and maintain it, right? So the further advantage is that reusability. So if you have created one project, and if you have to recreate another project with the base of this project, you can create a new project, not from the scratch. You can just reuse whatever that you have in the first project and create a new project based on that. So that is the other advantage, which is not available in all the other tools like Ant. Because if you're going to use Ant, then you have to rewrite all the code what you have written in the Ant script. Whereas in Maven, it is not like that. You can reuse the functionality to the maximum, and with just little modification specific to the project or the product, you can get the things done and you can start working. So this is just a comparison, and whatever I said is the same. Okay, so like I said, now internally, if you see, Maven will have some future similar to build tool, wherein you can use it to compile, create a jar, do some unit test, all those kind of stuff. And second thing is, it does act as a complete dependency management tool. So you look at this diagram. Okay, suppose I'm saying that for your project, all the circles are nothing but some kind of plugins or supporting jar files. Okay, so when you have to compile your product, all these jar files are needed, all these libraries are needed for the compilation as a dependency. Now if you're working on any tool like Ant, you have to manually, or you have to give a dependency of each and every file or the library what you're seeing here. Okay, now whereas that is a big pain, because even if you miss one, your compilation will not work. So you have to ensure that each and every library what you see will be referred. But if you're using Maven, the advantage is that it is going to act as a dependency management tool, which means you don't have to give a reference of everything. That is, you just give a reference of one file, and internally, based on the tree, whatever that it is going to have a dependency. That is, this jar, it will be dependent on some other jar. This jar will be dependent on some other jar, and this can be further dependent on something else. So these kind of dependency will be automatically taken care by the Maven, wherein all you have to do is just refer one file, wherein all the further dependencies or the child dependencies will be taken care of by Maven. And that is the other important advantage of using Maven. Okay, now it is also used by Maven to use some documentation, or you can use Maven to create some documentation for your product if it is needed. So these are some of the features what Maven is going to give us when compared to other tools. Okay. Okay, so far, whatever I was telling you is just overview. Now, before we go into the practicals, let's spend some time in today's class in understanding. First thing is the architecture. Then I told you that Maven will give us some standards, right? So we will understand the standard, and then I told you about the life cycle which Maven is going to give. So we will try to understand these things today, and from tomorrow we will see completely from the practicals. Okay. Okay, so freshen up your mind. From now onwards, you have to be, give more attention and try to grasp things. So please stop me and ask some questions if you're not understanding. Okay, so how Maven works. So the first thing what you need to know is for any kind of build tool. Okay, hello, are you guys there?
Yes. Yeah.
Yeah, yeah,
Okay,
yeah.
because sometimes I feel that I'm just talking by myself, so I need to just cross check. Okay, so
Mhm.
What happens is, no matter what kind of build tool that you're using, there will be a file called configuration file, or simply we call it as a build file. So what is this build file? A build file is nothing but a configuration file which will be used by the specific build tool. Okay, why do we need that? So this build file will be having all the configuration related details about a particular project, and it will instruct the build tool on what you have to do and how you have to do. Okay, so through this project file or through this build file, you will be invoking particular build tool. So in the same way, for Maven, there is a file called pom.xml, okay, which is nothing but project object model file. So this pom.xml is nothing but a build file specific to a project. So for that project or product, what and all you have to do, what is the build order, how you have to do the compilation or how you have to do the build, what you have to compile, what jars you have to create, what unit test you have to do, all those information related to a particular product or project will be defined in the pom.xml. And this is what Maven will be using, and based on that, Maven will be taking care of the build steps. Okay, so every product must have a pom.xml from the Maven terms. And if you see, the configuration file or the build file called pom.xml has to be present in the top level directory of your project. Okay, remember this point. It will be present in the top level of the product. Now, say that you as a user, you have one workspace. Okay, so when I say workspace, it is nothing but a directory which contains all your project files. Now, within this directory, in the parent directory, you will be having a file called pom.xml, right? So what is it going to do? So the pom.xml, if you see, it is going to contain some instructions which will tell Maven what it has to do, correct? Now, this will refer to all those details because this folder or this workspace is going to have all the source code. So now what Maven will do is, first thing when you are invoking Maven, it will check in the current directory wherever it is trying to run, it will check for this pom.file. Okay, so now using this pom.xml or using this configuration or build file, what it is going to do is that it is going to first take a list of all those things it has to do. That means it will read this file and it will understand that for this project, what and all I'm trying to do. Okay, now based on that, you would have instructed something, right? So now I told you that sometime back you have to instruct Maven through something called as goal. So now what you will say is Maven compile is what you will say. Now, in order to do the compile, what and all it has to do, that information it will read from this file and it will understand. So you will be passing some commands to the Maven called goals, wherein it will first read this file and get the information and work based on that. So in that terms, first Maven will try to take a complete list of the files, what it has to do build, and it will try to see how it has to do the build. Okay, and for the build, what and all is required. So for example, the basic requirement for the build is source code. Second thing, a compiler. And the third thing is if there is any dependencies. So it will take a list of all these three things and it will create the order in which it has to do all the steps. Okay. Now, when it has to do, it will find the source files in this directory. Okay. Now, what about the compiler? And what about the dependency files where it will fetch all these files. Now, in Maven, there is something called as local repository, or there is a directory called local repository where it will try to check for all those dependencies and all those files which it needs to support the build activity. Now, the question comes, what is local repository? So, whenever you install Maven, you will be getting a directory called local repository where all the Maven supporting files will be present. Okay, so whenever you're trying to perform some operation, what Maven will do is Maven will go to this particular local repository and check whether that dependent file or that file which is required to perform some operation other than the source code is present in this local repository. So basically, local repository is going to contain all those plugins or jars through which you will be specifying Maven to do something. So I said you perform some goal like compile. So for compiling, you need some plugin or some compiler, right? So that will be present in the local repository. And then I told you about the dependencies. So where is this all those dependencies going to be present? So Maven will check for all those dependencies in this local repository. Okay, so that is what the first thing it is going to do. So first, take a list of all the resources that is needed for doing the build, and then second, check the existence of those resources in this local repository and perform the build step. Okay, now when it is performing the build step, if the file is present, it will proceed further. Now, what if the files are not present? Or I am asking this question, how will all those libraries come inside this? Because when I said, when you are installing, you will just get one dummy directory and you will not be getting all those files internally, because one project will work on Java 1.7. The other project will work on Java 1.5. There will be one more project which is working on 1.8. Now, like this, how can Maven get all the plugin related to each one of them? So that means in the very first time, it will not be present here. So what will happen to Maven? So in those cases, what Maven will do is, first, it will check in the local repository whether all those resources or all those plugin which is required for doing the build of the project is present in this directory. Suppose if this is not present here, then it will go to the internet wherein there is a place called remote repository. So it will try to check in this remote repository whether all those required files or plugins are present. And if it is present here, it will copy to the local repository and it will start using it. So that the next time when you try to run the same command, it will go here, it will check, okay, the file is present, and then it will try to work. Now, in this concept, what is the remote repository? So remote repository is a open source repository which is maintained by Maven, because Maven is an open source project. So over the internet, there is a place where all the files and all the libraries required for build management will be present here. Okay, and this will be maintained by the Maven itself because it is an open source community. Suppose if you are interested in writing your own Maven plugin, because if you're good in Java, you can write your own plugin and submit it to the open source world, then everything will be available here. So this is the architecture how Maven works. So whenever you're performing some command or action for the first time, your local repository will not have that file. Then what Maven will do is, Maven will go to the remote repository, try to fetch the files or copy the files and put into your local repository and work from here. So it is very much important that you have to be always online, because when first time if you're working, if the files are not there, then it has to go to the internet to the specific remote repository and get the files. Okay, so this is how Maven works internally. Are you understanding this?
So it's going for remote repository in the sense
So
jar
we don't
file.
need to
Am I
tell
right?
Maven to go to remote repository and okay. Yeah. So I got it out. So if it didn't find anything in local repository, then it has to go to remote repository and get the thing done. So we have to want a Maven to go and get it, or else it directly searches in the remote repository once it's done with local repository.
It is the internal understanding of Maven. It knows where to go and check. We don't have to specify
Okay.
because it is just one open source community which is maintained by Maven. So we don't have to tell to Maven where to go and check.
Okay.
Yeah, Kumar, you had a question?
Yeah, it's very similar to that one. So the remote repository, what we're talking about,
Mhm.
it's specific to the compiler, or it's specific to which file is missing, or what it is looking for.
It is just one example I said. Now, just like that, for everything you need a specific plugin. For compilation, you need a plugin. For doing a unit test, you need a plugin. For creating a jar, you need a plugin. For creating a var, you need a plugin, right?
Okay, okay,
So like
yeah,
this, each and every activity that you do needs a plugin. For example, further, you want to do a deployment. How will you do a
mm-hmm.
deployment? You have so many application servers, right? You have Tomcat, you have JBoss, you have Glassfish, you have WebSphere. Now, how do you connect to each one of them? So for each one of them, you need a separate plugin. So like this, all activities which Maven will do is through plugins. So all those plugins will be present in the remote repository.
Okay,
Always work in the same order. That means first thing what it is going to do in Maven is whenever you are invoking something, the first step is it is going to first generate
Adam, your voice is breaking.
Hey, sorry, I was using headset. I just
Okay.
stepped on the mute button. I'm audible now, right?
Yeah.
Okay. So, as I said, the first step that it is going to do is generate all the source which is required for the build. And then for that step of whatever you're going to do, what and all are the resources which is required. When I say resources, that is what plugins it is needed, what libraries or what dependencies it is needed, all those lists it will be taking. And once it takes all the list, the next thing it does is compiling all the source code. And once you compile, then it will do a unit test. And once you do a unit test, it will do a package. Package is nothing but creating jar files, var files, or EAR. And once that is done, suppose if you have to do some integration between the components, it will be doing it. But this is not every time. It is just a one-off case someone will be using. But if not, you can ignore this. Then the next thing what it will be doing is install. So once the install is done, it will be doing a deployment. Okay, so to understand what is install, it is not just it is going to install something. Suppose you have completed here, that is you have created the jar or var. Now if one component is dependent on the other component, that means say that you have component 1 and you have component 2. So when you compile component 1, it is going to create something like 1.jar or 1.var. So let's keep it as 1.jar. And when you compile 2, a component 2, it is going to create 2.jar. Now the need is whenever I compile 2 that is component 2, it has a dependency of 1.jar. So whenever you're compiling 2.jar or whenever you're trying to create 2.jar, it needs to know about 1.jar. Okay, now as I said, where does it check for all the resources? Where will Maven check? It will go to the local
Local.
repository and check, right? Wherein if you are compiling 1.jar, you will be compiling the 1.jar in some workspace or in some directory separately, right? So how will Maven know that 1.jar is present in your local place? So in that case, what will happen? That you need to put the files from your working directory or from your workspace where you're trying to do the build to the local repository, isn't it? So unless and until it doesn't come to the local repository, Maven will not know where the file is, because this 1.jar is specific to your company. Will that be available in the remote repository? Logically, no, right? Because it is not something a common thing used. It is something specific to your product. So in that case, now in order to make sure that the files are available in the local repository, you use a step called install. All it is going to do is it is going to copy the file from your working directory to the local repository. Automatically, it will take care of that. So that step is called as install. Is that clear? I mean, is it confusing or you understanding what is install?
Yeah.
Okay, because when you are working on a complete product, this is very important because, like I said, any resources required like jar files like plugins or a compiler will be present in local repository. If it is not there, it will be present in the internet's remote repository. Now some file like 1.jar which is specific to your product, it will not be present in the remote repository. So obviously the compilation step will fail because first it will check for 1.jar in the in the local repository. If it is not find it is not finding it, it will go to the remote repository. And when it is not finding there also, it will fail. So what you need to do is whenever you have the dependencies, then after creating the specific jar, you have to run the step called install, which will copy the specific file from your local workspace to the local repository. Okay, so that is what called as install step. And after that, you have a step called deploy, wherein it is going to deploy it to a particular application server based on your need. So Maven will actually work in the same step and it will always be going from the same step. That is, you cannot just invoke only one step directly. If you say test, it will always come from the first step, compile, then come to test. Because to do the test, you need to first compile the file. In order to compile the file, you need to know what and all files has to be compiled, right? So like this, it is going to do the steps one by one in the same order. So you cannot just say that I want to do only install, I want to do only package. No, Maven is going to come right from the beginning to the deploy for all the times. But it is not that it will be doing all the step always. Suppose if you say package, It is going to come from the beginning and it is going to stop in the package. It is not going to go further. If you say test, it is going to come from the beginning and stop until this place, and it will not be proceeding further. So like that, it will be executing all the previous steps, or the initial steps will be the default, and it will stop exactly at that particular phase where you have instructed Maven to do. So if you say Maven and some particular phase, it will execute from the beginning and it will stop at that particular phase. If you say deploy, it will do everything. If you say install, it will do from here to here. If you say package, it will do from here to here. So this is the default lifecycle which Maven will be working on. And if you remember, I said when you are instructing Maven, you have to specify some command through goals. So what are that goals? Those goals are nothing but these things itself. So this is what you will be instructing to Maven. Maven compile, Maven test, Maven package, Maven install, Maven deploy. This is how you will be invoking Maven with these specific goals or the phase of the life cycle. And remember, you have to use the same string what you're seeing here. Only then Maven will be understanding. All right. Now, so this is the default lifecycle which Maven will be working on. In addition, Maven also has some other phases. So that is called as clean and sight. You don't have to worry from sight. Let's understand what is clean. So now clean is also part of a Maven's lifecycle, but it is not part of the default lifecycle, which means if I invoke clean, only clean step will be done. It will not invoke anything like I said. So if I said test, it will invoke generating, compile and test, right? But it is not in this phase because it is an independent phase. So if you say clean, it will be performing only the clean and not anything else. And what does clean do internally? So if you see, clean is going to delete all those runtime created files by your project. So if you see what and all are the runtime created files. So when you do a compilation, you will be creating some class files, right? So all those files will be deleted when you invoke clean. When you say test, what is that you're going to do? You'll be creating some reports, you will be creating some test related files, right? So all those runtime files related to test will also be deleted by clean. And if you further see, when you say package, you'll be creating a jar var, right? So those jar or var will also be deleted by clean. So all this runtime files which has been created by Maven to do your project's build is what clean is going to delete. So you don't have to tell anything what to delete. It will automatically delete everything with respect to a particular project. Okay, so if I take some examples now, this is how it will be doing. So MVN is the executable which will be calling Maven, or MVN is nothing but a Maven executable. And if you are going to invoke some option, this is how you will be passing options or passing goals to Maven, wherein you will be instructing the phase or the goal wherein it will internally do some step. So now if you say Maven install, wherein install is nothing but a goal that you're passing to Maven on what you have to do. So as I said in the previous slide, if you say install, what is it going to do? It is going to first come from the first step, generating the resources, compiling, test, package, if there is any integration you do, and then come to do install. If you say clean, it is just going to invoke only the clean and not do anything. Suppose if you are passing two parameters or you're passing two goals, then it is going to perform one after the other. That is the first whatever goal you have given and then the second goal. Okay. Now take this example wherein I am passing two goals, that is compile and install. Okay. But if you see, for compiling, I have to generate the resource and do compile. And again for install, again I have to generate, compile, and do all those things, right? So in this case, do I have to do things twice? No, Maven has the intelligence to know that as soon as you first do this step of generating and compile for this compile, and when you come back to install, you have to still do the same, but it will not do, it will just proceed. Why? Because even though for install you have to generate and compile, you have already done the same step for this particular goal. So it will proceed from that step what it has to do further, and it will do all the others, and it will stop until install. Okay, so it is the same like here. If you say test and clean, first it will do all the steps which is required for test, that is generate, compile and test, and once that is done, it will execute the next phase or next goal called clean, and it will execute that particular steps related to it. So this is what Maven will be working, and going forward whenever we are instructing or working on Maven, this is what we will be passing on. So are you guys understanding it? Any doubts or questions in it, or it's not clear?
It's clear.
Kumar, Hemant, any doubt?
Yeah, I'm fine.
Okay, so when we are working on practicals, this is what we'll be doing. We'll be invoking commands like this only. So why I'm explaining this in deep is, you should first understand this. Only then when you're trying to run some commands, you'll not have much doubts from the logic. The only thing is we need to look more into what these things will do. Okay, fine. Uh, okay, so the next thing what I said is it gives you a standard. Right? So I said Maven is a project management tool wherein it will give you a standard and a life cycle. So we saw from the life cycle. So now let's understand what is the standard that we have to follow. So the standard what we have to follow when we are working on Maven is that it is a directory structure which you have to follow. That is the project on which you'll be working, right? It has to follow a directory structure which Maven will understand. Only then Maven will automatically take care of everything. Because here in Maven, if you go through the practicals and when we are seeing, you will not be specifying which file you have to compile, what jar file you have to create, what you have to delete. You don't have to tell all these things. When is it possible? It is possible only if you follow certain directory structure. That is, whenever you're trying to work on Maven as a build tool, the product structure should be in this way. That is, you should put everything inside a folder called SRC. Okay, so SRC is going to contain all your source code, wherein it is not just directly dumping everything in that. Further, you have to follow a structure. That is, inside SRC, you are going to create a folder called main, and in that main, you have to create a folder called Java and put all the source code related here. That is, all your Java files will be present inside a folder called SRC main Java. Okay, and suppose if there are some supporting libraries that is required by this Java, then you have to create a folder called resources inside src main and put inside it. And in case if you are working on a web application, then you might be requiring some configuration files or some XML files. Then all those kind of files will be put inside src main assembly or config. And anything specific to web application, then sources for that will be put inside src main web app. Okay, now this is the structure which a developer has to follow and put all the files inside it, so that when we as a build engineer, when we take it, this is what we will be taking it. Okay, now going back to the first class on SEM. So when we create a scratch repository, what we will be doing is that as a build engineer, we should be creating these dummy directories inside that repository, and we will be storing it in the central repository. So from there, if a developer is trying to use, he will be continuing his development by putting the files specific to these directories. Okay, so if a developer is not doing it, then when we as a build engineer or a CM engineer, when we creating a repository where we are going to store these files, we will be creating the structure similarly. Okay, because when I am trying to work as a build engineer or a developer, I will be taking the source files from the SEM tool. So when I take the files from SEM tool, I will be getting the files in the same structure what you're seeing, so that immediately when I invoke Maven on top of that, it will be working. Okay. So now this is one structure. Now, since if you see for a Maven, you also have a unit test files which is needed, which is also be written by the developers. There will be a folder called src test, and you will be following the same structure wherein the test folder will contain all the test related resources or test related files. So for every Java code a developer writes, there should be a corresponding test code which is going to used for testing whether the file is written properly or not. Okay, so src main will be used to store all the source code, wherein src test is going to be used to store all the test code related to this source code. Getting it? So this is the structure which we have to follow. So for now, you just try to remember this. Tomorrow, when we are going into the practical, we will be creating the structure and we'll be putting some dummy files as a project. Then we will be creating some POM file. That is what we saw, right? We will be creating those POM file and we'll be working more into it. Getting it?
Yes.
Yeah.
Okay, so this is the directory structure, or this is the standard which we have to follow. Suppose if you're using Maven, because if you don't follow this structure, what problem will happen is Maven will not understand anything. Then you have to take a pain on instructing each and everything, saying that my source file is in this directory, my resource file is this in this directory, my dependency file is in this, the unit test file is this is where you have to compile, this is where you have to put the jar file, all those things you have to write. And that is the pain why people are trying to go with not going with ant and they're going with Maven, because when you're using ant there is no structure like this and you have to instruct each and everything. So assume that if you have 100 files, you have to indicate all the 100 files to Maven. For each directory, you have to tell that this is a directory, this is a file here, like that. So when you are using Maven, you don't have to do, because you will be following this standard directory structure. And Maven will try to do all these things by itself. Okay. Now, before we close, there is one more thing which we need to understand is, so I was telling standards, I was been telling you that we have life cycle phases based on which Maven will be working. Wherein internally I said one more thing. So anything that you instruct to Maven is through something called goals, wherein goals are nothing but plugins or jar files. Now, if a question comes, how does Maven identify which plugin that it has to use? Because that is one more thing which you need to know. And how does Maven identify that is something called as coordinates. So this is a question for you guys. What do you understand by coordinates? A general word. Don't think from technical terms or anything. It is not coordination, it is coordinates. Have you heard this coordinates anywhere so far in your life?
In maps, graphs, x coordinate, y coordinate,
Exactly. So what is the need of that?
uh, to show the different path.
Hmm, okay.
Access.
Yes. What is the need of that?
Just distribute the data.
It's
Like
coordinating 2 points.
Okay. Give some other example. Where have you seen coordinates other than that? In the ship, sailing, do you use some
yeah,
coordinates?
yes.
What is it going to be
To
used
show a
for?
path, like to know a direction, like
to give a specific path or something.
Uh, path is right, but okay. So it means it is giving some reference, right? Path, what do you mean by path? You have to refer saying that you go there. Only when you go, it'll
Yes.
become a path, right?
Yeah.
Even in your graph, you point to something, you do draw something. What you're drawing is separate, but how you're drawing is a reference. So in that way, in Maven, there is some coordinates through which it will be identify any plugin. It is not just the plugin, it is using some coordinates. It will be identifying your project itself. Okay, so in those understanding, what is the coordinates what Maven is going to work on. So if you understand that, there is something called as GAV. Okay, this is what we call it as Maven coordinates. So GAV is nothing but a combination of three strings through which Maven will be identifying a particular plugin or a project. So if you see what is that GAV, G stands for group ID, which is nothing but a string which refers to a company, or it refers to a business unit of your company. Then what does A stands for? A stands for artifact
Hmm?
ID.
Chuma అవసరం లేదురా నీ వాడిపించుకుంటుంటది.
Okay, so A stands for artifact ID,
అదే
which
అది కాదురా
means
మ్యూట్లో పెట్టు.
so A stands for artifact ID, which is nothing but the name of what you're trying to build. So like I said, artifact is nothing but the deliverable what you're going to give to the customer. So artifact is a string, or artifact ID is a string which is going to represent what you're trying to build from that project. And finally, V stands for version ID, wherein it is a combination of some three digits. Okay, so what is that? So generally when you say version ID, it represents three values, that is major, minor, and maintenance or patch, wherein all these things are number. So if you are working on some tool, if you go to some help menu, you will be seeing some build number and it will say the version as 1.0.1, 2.0.1, 3.0, something like this. You will be seeing the numbers, right? So those numbers are nothing but version which is used to represent a particular release. That is, the first number represents the major release, the second number represents the minor release, and if you have a third number, that represents the what? The maintenance or the patch number. So by using a combination of all these three, Maven is going to identify any plugin or project. Okay, so this is how it is going to use. So it is going to use a combination of group ID colon artifact ID colon version, and using this it will be identifying a plugin. So sorry, if you are saying compile, so for internally for compiling, there is some plugin which is there, right? How is it going to identify that? Yes, it is going to use a combination of three digits like this, sorry, three strings like this, and using that, it will be identifying. Okay, so for now, please have just an overview of this. And tomorrow, when you are going internally from the practicals, we will see each and everything what we just saw now. Okay, the life cycle, the stand directory standard, the plugins, goals, the GAV, each and everything we will be seeing all those things. But at least are you getting something with respect to GAV? So GAV are nothing but a coordinate which Maven uses to identify a particular plugin. Okay, and it always
For
works in this format.
Adam, I have one question.
Yes.
For each project, we need to maintain the different Maven directories, right? I mean, If this is the case, the group ID will identify the particular project. Suppose I have a XYZ, three projects. One is for, the specific operations. The B is to something else. I mean, C is for some other specific. So for all these three projects, we are driving this build management. In the sense, for each project, I need to maintain this directories, right?
Exactly. So directories, okay, don't confuse with the maintaining directories. Now, why do you need a directory? You need directory so that you will have some specific files related to a project and you do something, right? Now, only when you want to do a build for a project A, now, okay, I'll be putting it very simply. So, where does the developer store all the files, or where does he store all the files related to a product?
SCM,
It's a
like
local repository. It's a local directory. Say.
No, no, no. That local is for his usage, but where he'll be storing it permanently?
Git or something, Subversion Git.
Yeah, it'll be in some central repository, right?
Okay.
So
Yeah.
now, what is our aim as a build engineer? We need to do a build for some latest change what we have to do. Okay, so then what is that we have to do? We need to get the files from the repository, right? That is when we do something called a clone and we create one workspace in whatever system or server that we are going to work, and inside that I will be getting all the files related to the product. Is that clear until that?
Yes.
Okay, so
Yeah.
when you get the files, now how are you going to compile? It is using a tool called Maven. So if you are using a tool called Maven, the files inside that folder or the workspace which you have just created now should be in a standard structure. Okay, and that is what the developer will be following whenever he's trying to do a check-in. Okay, so whenever you get the workspace
Okay.
from a particular repository, you will be having the same structure as the Maven will identify. Then all you will be doing is go inside the directory and run the Maven command and compile it. So this is what we did in the continuous integration job in Jenkins. You remember, I had one repository maintained. I had some similar directory structure called src, main, Java. What we did, we just took that and we put inside some a folder called workspace slash CI, wherein we had the same structure. After that, what we did, we went inside that and we ran some Maven commands, correct? So
Yeah.
like that, for each product, when you want to compile, you will be having separate folders. So you will create folders only when you want to do a project for a, I mean, if you want to do a build for a separate project. Suppose if you have two products to be built, then you will have two separate folders created and you will be doing build separately on those two folders. You getting it?
Yeah. Bits and pieces.
Yeah, so don't get confused. You don't see everything as one. So when I say group ID can be common, but artifact ID will not be common. Version ID will not be common. So see, that is what I was going one by one. So why did we see first from the SCM is that as the developer, he will be doing his changes in his local workspace. Yes, but that is not going to be stored permanently in his place. That local repository is only used by developers for his development activity. So as soon as he completes the development activity, he will be putting the files into a to a central repository. So now we as a build engineers, we need a copy of all those files which is present there. So for that, what will we do? Will I be directly going into the central repository and I'll be doing the build? No, right? So how is that possible? So we need to create a copy of that central repository to my laptop or to my server, and from there I'll be doing some build steps. Logically, yes or no? Correct, right? So
Yes.
like this,
Yeah.
For each product, there will be separate repositories available. So whenever you want to do a build for that particular product, you will be creating a copy or a clone of that specific repository into your server, and you'll be doing so like that. For each product, you will be having one directory or one workspace. Is that clear?